Today we are going to start chapter 10. In chapter 10, we have three topics: separation of variables and the slope field. We learn in calculus AB, and Euler's method approximation, and the population model is new in BC. So let's have a look at lesson 1, separation of variables. Let's look at warm-up problem number 1. So if you look at here, y prime equals e to the x plus 2. So for any equation have derivatives, we call it a differential equation. How do we solve this simple one? We just take the antiderivative. Give us e to the x plus 2x plus c. And this is what we call the general solution. Let's look at example 2. Determine if the following function is a solution of the differential equation here. How do we check if the function is a solution? We just need to plug this in. If the left equals the right, then it's a solution. For example here, if we plug y equals e to the x in, so because y prime equals e to the x, we will plug it in, e to the x minus e to the x, it is 0, so it satisfies this equation, so e to the x is a solution. You can check this one yourself and compare with my answer key. Let's have a look at the separation of variables. For some of the equations, we can use separation of variable to solve the differential equation. So what does separation of variable mean? We are going to separate x and y on two different sides. For the problems, if you have y prime, for example this one, if you solve y prime equals negative 4x over 9y, you look at here, we have y on the left and y also on the right. We cannot take the antiderivative directly, so we have to use separation of variables. First, we write y prime as dy over dx. We move everything on the x to one side. Next, we move x on one side and y on the other side. We take the antiderivative here. This step is what we call separation of variables. And then we solve the problem. Here we will have 9 over 2 y squared equals plus c. Sometimes if you look at this problem, I have y on both sides and we have the initial condition here. So in this case, we have to solve for c. So we write dy over dx. So it's dy, 1 over y dy equals 2x dx. We take the antiderivative, so it's ln equals x squared plus c. So if you want, you can keep the absolute value here. It's okay. So y will be e to the x squared plus c. This will be e to the x squared plus times e to the c. As we know, e to the constant c is also a constant, so we're going to write y equals a times e to the x squared. This is our general solution. If you don't like a, you can replace this a using c, any constant. Now we are going to plug y1 equals e in. So e equals c times e to the first, so equals 1. So y equals e to the x squared. This is our specific solution. Or sometimes we call it particular solution. This is what we call the separation of variables. I have a worksheet here. You can work on this and compare with my answer key. And the slope field. So the slope field is the slopes. Show us the slopes at all the points here. So let me go over one problem. Let's have a look at this one. So if you look at y1, when x equals 1, y equals square root of 2 is somewhere around here. Somewhere around there. So if you look at the slope here, slope should go negative. So the slope field, based on this point, we can have a very good idea. Our slope, our curve, our y function should follow the slope. Should look like something like this. it looks like a circle. Let's have a look at the solution. So dy over dx equals negative x over y. So it's y dy equals negative x dx. It's y squared over 2 equals negative x squared over 2 plus c. So when x equals 1, y equals negative 2, we plug it in. So it's 2 over 2 equals negative 1/2 plus c. So c equals, so it's 1 plus, so it's c equals 3 over 2. So our equation y squared over 2 equals x squared over 2. So it's x squared plus y squared equals 3. So it's a circle with radius equals square root of 3. So this is the slope field. This slope field gives us an idea what the solution for y look like given any point. So you can finish the rest of the problems and compare with my answer key. Here's my answer key for number 1 to number 6. And the slope field.